Alright, here I am doing page 1. I apologize, I should have had 10 numbers here, which would have made the division much easier. Somehow it got left off, I'm not sure. But at any rate, we got 9 numbers and we can kind of power through this. If we are asked to find a 5-interval relative frequency histogram, I just made 5 compartments. These are all less than 50, so I thought that would make fairly straightforward sense that you would just go from 0 to 9, 10 to 19, 20 to 29, 30 to 39, and on up to 49. And when you put the points, I just wrote them here to fill in the little boxes and give you a sense of what the histogram is like. And you wind up with a very boring distribution that is almost uniform. Maybe you could say it's skewed. I just said not much. On the test, it'll be pretty clear what it is. So know your basic shapes for that histogram. Mostly I'm warning you what the test is going to look like, and so you want to know those. The mean then is this sum, which is 240 divided by 9. It would have been great if it was 10, but it isn't. That's very close to 27. It's 26.6 repeating. But we'll just round to 27 to make it manageable. It's supposed to be no calculator, but I think that you'll be allowed to use small non-TI style calculators. That's not a big deal. The median value, the middle value, is 25. The mode is most often occurring number, and that's 15. The range is from 15 up to 45. I do not see any outliers there. Outliers tend to be more than like 2 standard deviations away, more like 3 or 4 or 5 to be really extreme. Then finding the standard deviation. I'm not taking the time to write this all out in detail to spare you that. I think we've done this several times, but once you've found that mean value, the x bar, we subtract each point from that and square that value, and then we add that all up. So I got it started here, and here's all of my numbers right here. I have 15 3 times, and all the rest of the numbers occur only once. When I sum that all up, I get 1051. I divide that by 9, so you take the sum of these differences squared, and don't forget to divide. You kind of average that. That 116 is what you square root, and it's around 10.9, so that's my standard deviation. Okay, make sure you identify it. Don't just leave a number floating on a page. Alright, so there you go with that. Now, using the concept of standard deviation to solve this problem, the average arrival time for Pingree students is, the time of day is 7:49 with a standard deviation of 10 minutes. Okay, so just sketching a real simple normal distribution like this, which is implied by the fact that I've given you the standard deviation. That's 7:49. So I'm just going to write 49. And then if it's a 10-minute standard deviation, right there is going to be 59. Right there is going to be 809. If I go 10 minutes earlier, I'm at 7:39, and then 7:29, and so on. And these are 34, 13.5, and that's 2.35 up till that's 8:19. And then you have a little tiny bit in the end of that. Approximately what percentage of students arrive after 7:59? So that's up in here. Well, if that's 34%, I add that to 50%, and then I take that away from 100%, and I'm going to get 16%. Okay, that's the 13 plus the 2.35 plus all the little bit. It's easier to do it that way. And then approximately how many students? We're looking for a number here. We've got the implied student body population of around 340. You could say 330 to 350. That's not a huge deal. Between 729 and 759. So now I'm dealing with this area in here. And that's going to be 34 plus 34 plus 13.5. Alright, so that's going to be, 68, 78, 81.5 when you add up those percentages. It's like I said, 34 plus 34 plus 13.5 arrive between that window of time. Alright, hopefully that's enough. Good luck.